So both of the examples today are going to be of the automotive genre. I just happened to find two automotive, and automotive is a huge one for the software. So there's just a lot of applications. With these two, these are the types of scanners that are used on this specific first application here. So you'll notice there's a bunch of handhelds and white light scanners. I believe this one was a handheld scanner, that the first application. But these are the types of devices that would be used with this type of application as we jump forward here. And in this one, it's an automotive stamping example here. And we see these all the time. There are just millions and millions of automotive parts that are manufactured every single day. And some of them need to be remanufactured or have third-party companies pick up and start manufacturing when the OEM goes out of production on certain parts. So this is an example. Sometimes I don't have the exact part of the individual one that I have here as far as an image to go along with it. But you can see that this is a stamping die that was creating a sheet metal part. And as you can see, it's a pretty complicated one. So I will go ahead and toggle over to Design X, and we'll do our rollback technique of going back and taking a look at how this part was modeled. And we'll just go ahead and select Design X, and you'll see here's the final product. Really cool, really elaborate CAD model here that we're able to take the scan data and create the CAD model. Now, as usual, I always bring up one of the neat things about Design X is the fact that it's a history-based CAD modeler. So the way Design X evolved here as a product line is we saw that need in the market. 3D scanners were coming on the scene many, many years ago as products being used in manufacturing, and CAD softwares had no way to deal with that information. And there was no one on the horizon that was looking at how to fix that problem. So what ended up happening is we created a scan kernel of tools, like a tool set of software that can load these thousands and thousands of points, millions of points now. But at that time, scanners weren't anywhere near as high resolution as they are now. And we took those and married them with a CAD kernel. So as I stumbled over there before, a scan kernel and a CAD kernel coming together inside of one software. So scan data is a native entity inside of our software. I say that a lot of times. So if you guys heard me, I kind of harp on it, because if you try to load something like this mesh right here, it's only a million triangles right now, which is nothing for us, right? But still, a million triangles when you load that into another software is very difficult to deal with, right? And they don't have a whole host of tools that you might need to work with that data. For example, like if there's a part of this model you just need to get rid of, like I just click on this flood fill and say, I want to delete that. There's all kinds of tools like that are built into our software that I can interact with scan data and CAD data and switch back and forth between them throughout the design process and not have any issues along the way. So we'll get started here. So this is the scan data, and we'll just do roll forward. As we talked about, it's a history-based CAD modeler with scan data, not as a second-class citizen. And one thing that I started to do as we go through these webinars a little more often is I just place these dummy points in the rollback history so I can help us streamline going back and forward through the history. So if I just say I want to roll forward to this dummy point here, and it will show the snapshot of where we are in the history of this model, so we can learn how the person that designed this, how they went about doing it. So as you can tell, I am not the original modeler of this specific part, but I am able to roll back through the history and learn how this person went about modeling this. And this is one side effect that's a benefit from history-based CAD modelers that's really nice, is being able to do this. So you see here that we went ahead and we did a couple different lofts on the surface, and those lofts were generated not just by creating a loft manually like you would inside of a CAD software, but you actually can come in and I can select a region like this. I can come over to our wizards and I can say loft wizard. And I've shown this tool, I know, a lot of different times, but so many people have not seen this and how cool this tool is. So you see here, this bounding box is kind of my envelope for the surface that's going to be draped onto this region that I've selected. And then I can adjust how many, let's just drop it down to 5 for a second. I can drop it down to 5 cross sections. And you see here that I can up that to 7, and I can adjust those dynamically. And then you'll see if I hit next, it will create a preview. I can type in the resolution of those curves. I can stop and I can do an accuracy analyzer. Now, if I want this to be entirely smooth, you know, I can leave it as is, but if I need it to follow certain areas closer, I can hold the control key and I can drag out other cross sections here. And create more sections that will follow closer. So once I'm happy with that, I can turn this off. Hit OK. And you see that I've created a lofted surface. So that is what they went through on these right here. They went ahead and created multiple surfaces. I just show that just so everybody can see how it was done here. So if we go ahead and roll forward, I'm just going to come in here and roll to my next rollback spot. You'll see the next stage is they went ahead and trimmed that whole top section together. So we'll go ahead and turn off the regions so we can see a little bit better, and we'll turn off my surface that I created right here. So now you see that we've created this whole like backstrap that goes all the way down the side here. And that's going to be kind of the theme of how this is modeled along the way, is going ahead and creating a surface for the top and surface for each side and trimming them all together to make them fit and create the surface. So if we go ahead and toggle forward, roll forward here, you'll see now we have the side surface that we've stitched together. So the process was exactly the same. Just like that. Let me just get a drink here. Clear my voice here. So you see, the top one was simple. We were able to fit a bunch of stuff really quickly and easily. Now the side is a much more elaborate, and we've trimmed and stitched a bunch of these together to create this side surface. And I'll go into a little bit of how that was done in the next section here. Now we'll go ahead and roll forward. And you see how we trimmed all those trim surfaces together. Really neat how that process is. So we'll just keep walking forward. And you'll see the side surface here. Just give it a second. There we go. Pardon me, I'm still getting over a little bit of a cough here. So now you see here that we have this side surface and the top surface. And real quick, I'll talk about this one more time. We've brought this up a few different times, but sometimes you have two different surfaces that are coming together and they don't quite match up with each other, right? And what you can do, and I'm just going to show a down and dirty example here. And we will, I'll just show it based on these two surfaces. One trick in here is it's very easy to come in and just do a surface trim with curves. So I could come in and say, hey, I want to draw these curves here. And I want to draw these curves here. And then I can come over once I get out and I can say, I want to do a surface trim. So I'm going to say, this is the tool entity. This is the surface entity. Keep this side. And then we're going to say, we're going to do the same thing on the opposite side here. Tool entity, target, tool again, because I messed it up. Keep this side. And then you just come over and say, I want a loft between those two. So if I say I want to do a surface loft between here and there, and then you obviously have the ability to adjust the tangency and the direction vector of both sides here. Or you can even add guide curves along each of these in order to create these constraints here on each of them. Actually, I can turn off, I selected the curves, but I can do the edges. And the edges will let me do curvature, like so, and blend those together. So you can, we'll just complete it so you can see. And I didn't do the best one, but I'm just trying to show the concept of what we're doing here, and how they're able to trim these together. Sometimes you can fillet two surfaces together, but if you cannot, you do a manual blend like that. And that is a technique that is used a ton in this application right now. So we'll continue with our rolling forward here. We'll go ahead and get rid of my sketch just in case I mess something up along the way here. But that skill set of being able to do those surface trims is huge. So we'll just give it a second to respond. Whenever we do a presentation online, it's a little more difficult to roll back and forward through a history tree like this that's long, just because of the meeting. So with this one, what we were able to do is then trim the sides, top, sides, and this little piece together. So they modeled this as a separate piece and then cut it away as well using this surface trim right here. So if we just keep rolling forward to our next snapshot spot. So this is showing, and we'll just turn the mesh on, that after we do this back strap area and both sides, now there's a flange on each side. So rolling forward, and you can model these a whole host of different ways. It all depends on what the customer is trying to accomplish. So I can make these more feature-based. You can make these follow exactly like they are here, where we're fitting directly to the mesh and allowing it to be highly organic shapes here. But you can, the beauty of Design X is that you can do either or. I can fit to what's there, and then, or I can make it very idealized, right? So we went ahead and we modeled all of these trim all together. Wonder how many trims there are in this whole project here. It's quite a few. So we trimmed all of those together, and then they continue on through to the other side. So we trimmed all of those, all of this together into a big old surface. It's still separate from this one. We haven't trimmed it in yet, which that's coming up here in a second. If you go forward, then this all gets trimmed in with that. And then obviously you'll see here that they add all of the fillets, all the fillets to that, and then keep moving. So you can see just breaking it down into the separate pieces of surface trimming. So the theme of today is going to be lots of surface trimming, actually, as you see my next application too. Because for certain very complicated parts, this is going to be a skill set that comes in handy to be able to deal with these parts. And the more organic and complicated the part is, the more Design X really shines of being able to create all of these surfaces so quickly. As you saw when I made that lofted surface earlier, imagine having to make all of these lofts manually and draw them out manually. And we're just fitting, trim, all these together. While this is a larger project here, it's still so much faster, exponentially faster, to do it this way versus trying to do all of these lofts manually. So now we got the two flanges trimmed in with the center backstrap. And then now what we're going to do is there's a couple offset areas right here where they cut these little channels out of there. So there's one of them. And then after that, they have a few different features that they fit. So here's the other one too. There's another channel where we're going to cut that away. And you'll see if I just roll forward here. Now, roll forward there. Now you see that we've added a ton of the hole cuts, which all of those you can, there's a bunch of them you can combine together if they're on a similar plane, right? So if they're on a certain direction, a lot of these you can cut all together with, I believe it was this one right here. Let's see here. Yeah, so look at all these holes that were cut at once. So we cut the outer boundary, did an outer boundary surface extrude and interior holes and modeled all those at once. And then you'll see there. So let me re-show my screen. For some reason, the maybe it's back. So GoToWebinar sometimes just struggles with showing stuff like this. It's heavy graphics oriented. So you'll see here that we cut the outer boundary and the holes all as one. And there's only a few more steps here, and roll forward, cutting a few more of the holes. And then, of course, one of the huge benefits here is turn on deviation for body, and you can just look at the deviation and see how close it's fitting. And again, with the deviation, you're making the decision whether or not it needs to fit exact. If this needs to be flat, it needs to be flat, regardless of whether the scan data is wavy or not, right? So you're making the decision whether that's good or not and how close it needs to follow. So this color map is not a pass-fail because we're reverse engineering it. We're making it whatever we need it to be. And we're making those decisions along the way.